Hey guys, how's it going? Mr. Dorado here with a brand new unit this time. So I'm bringing a brand new video on Unit 6. So we are going to get started on this brand new unit, which actually has a lot to do with exponents. So we're going to actually be covering a few rules here in this particular section. So section 6.1, where we talk about the 4 multiplication rules of exponents. So before we go ahead and do that, let's actually go ahead and start reviewing with a little bit of vocabulary here. Okay, so what I'm going to go ahead and do is, let's see, grab my highlighter here. So when you talk about a base, you are talking about a large number in comparison to an exponent, which would actually be the smaller number hovering right over it, okay? So when you have a number and it's raised to a power, that number is called the base. And then the power it's raised to, that would just be its exponent, okay? So I'm sure this is very familiar to what you guys have already learned, but now we're going to go a little bit more in depth, okay? So let's just remember those two keywords, guys. Base, which is the bottom tall number or the big number, and then the exponent is just your power, whatever it's raised to. All right, so let's go ahead and read rule number 1, the product rule. Okay, this one again is called the product rule. All right, that's basically what we're going to end up doing is adding exponents. But let's go ahead and talk about or look through a few examples here. Okay, so if we start looking at this example right here, it says 5 to the third power times 5 to the fourth power. Okay, so I want you guys to notice something here. We have the same base in uh, both of these values here, right? And we're multiplying something that has the same base. Okay, well, let's just keep that in mind and in the back of our thoughts for a second. So this first one says 5 to the third power, meaning I have exactly I have 3 5s here that I'm multiplying. Okay, so 5 to the third power, all that means is I have 3 5s that I am multiplying. And once again, we are doing times here, so let me go ahead and highlight this. Times, okay, another set of 5s, which in this case is 4 5s. If you guys notice this exponent here of 4, that just means I'm going to have 1, 2, 3, 4 5s, okay? So let's just be clear. 5 to the third means I have 3 5s. 5 to the fourth means I have 4 5s. Okay, so what does that tell us? Well, notice how many I have in this entire thing now. Okay, I have 1, 2, 3, 4, 5, 6, 7. I have 7 different 5s. Okay, how many 5s do I have? I have 7 5s. Okay, that's the number of factors that I have. And because I have 7 5s, then I can do this. That means if I have 7 5s, I can write it as 5 to the 7th power. Okay, that's what my product is as a power. Okay, so again, 5 to the third times 5 to the fourth. I just wrote them all out, and then now I notice I have 7 of those 5s, so I can write it as 5 to the 7th. So let's go ahead and actually do a similar problem over here on the right. Okay, so let's go ahead and write a few things down. So the first thing I have, notice again, I have a base here of x and a base here of x. So we're dealing with x's, but now here I have 2 x's. Here I have 5 x's. So let's go ahead and do those, or rather write those down. So I have 1, 2 x's. Okay, so let me highlight those so you guys can see where I'm getting those x's from. So that's from my original 2 x's, my x to the second power. Now this is going to be times my x to the fifth power, which is basically just 5 x's. Okay, right, and again, these are my yellow ones, so let's go ahead and highlight these. 1, 2, 3, 4, 5. Okay, so now it's asking me, okay, how many factors of these x's do I have? Well, I have exactly how many? Let's count them up. 1, 2, whoops, probably should use a different color because I can barely see that. So, let me use a different color here. So we have 1, 2, 3, 4, 5, 6, 7. So how many factors of x do I have? I have 7 factors. Okay? Okay, I have 7 x's. So then if I want to write this as a product, I would write x to the 7th power. Okay? Now, down here, it says what? It says, what did you notice when you wrote the product of factors into a power? And you should have noticed this right here. You should have noticed that you must add the exponents. Okay? So let's make sure that makes sense. Okay, what are the exponents in this first problem that we did over here? Okay, well, it was 3. Let me write that down real quick. So it was an exponent of 3 and an exponent of 4 that equaled 7. And look at that. That matches that exponent. Same thing here. I had a 2 and a 5 for my exponent. That equals 7. And again, look at that. That matches my 7. Okay? So again, what is the basic rule here, guys? Whenever you're multiplying things with the same base, you have to go ahead and add the exponents. Okay? So why don't we actually go ahead and look through a few of these problems. So it says, simplify the following expression. Okay? And even before I do that, I want to make sure this is clear. On letter A, it says x squared times x to the 1. Okay, if it doesn't have an exponent up there, just know that it's a 1. And similar with this x, that is also a 1. And now if we follow the rule, we said that all we have to do is add the exponent, so that would be 2 plus 1 plus 1, which would be 4. So my final answer here is x to the 4th. Okay, let's keep going. Again, here I have something with the same base. Again, remember that's the rule. They have to have the same base. Okay, I'm multiplying something with the same base, which means that now I can add my 1, 2, 3 exponents. So 4 plus 6 plus 2, that's actually a 12. So my final answer here is 6 to the 12. Okay, and you guys can actually go ahead and figure out obviously what 6 to the 12th is in your calculator, but it's quite a large number. I don't think we want to figure that out right now. I think for now we just want to be able to make sure that you can figure out that if we have the same base, we have to add the exponents. All right, so before I even start part C, yet again, remember guys, put a 1 over the y if it doesn't have any number up there. Okay, that one also didn't have an exponent, but I can also put a 1. Now, remember our rule, guys. This only applies if we're multiplying things with the same base. Here my base is x. The next one, my base is y, so I can't do anything with that. This one, my base is x, and this one, my base is x. And again, that last one is a y, so I can't do anything with that. So what I'm going to go ahead and do is add my exponents. So let's see what I get. I have a 2, a 1, and another 1. So 2 plus 1 plus 1, that is a 4. So my first number there is going to be x to the 4th. Now, there is 2 sets of y's here. Okay, so let me actually go ahead and highlight that. So this is a y, and this is a y. So I can, oh wait, oh, I made a mistake. Let's go back. Let's go, rewind, rewind, rewind. Okay, so I made a quick mistake here, guys. And hopefully you guys spotted it before I did and didn't make the same error, but if you did, it's okay. We all make mistakes. this right here is the exponent I should have circled. Okay, so it's actually 2 plus 5 plus 1. That is actually 8. So this is x to the 8. All right, now we got that figured out. Let's go ahead and look at the y's now. I have a y to the 1 and a y to the 3. So I add those up. 1 plus 3, that is a 4. So the second part of this is going to be, so x to the 8 times y to the 4. Okay? All right, so again, the rule was when we're multiplying items with the same base, all you have to do is add the exponents. Okay? All right, let's go ahead and take a look at rule number 2. This one is the power rule. Okay? This is the power of a power rule, or multiplying exponents, and we'll look at why it's called multiplying exponents. So now look, let's go ahead and recap here. So if we look at this first problem, okay, problem number 3, okay, if we look at that one, we notice that we have a base of 5 and an exponent of 2, okay? But then notice then that is also being raised to another exponent of 3. Okay, so let me highlight that one. So an exponent of 3. So what does that mean? That means we have 3 5 squareds, okay? So we have 3, 1, 2, 3, 5 squares, okay? But we said earlier that that 5 square, I can split it up into 2 5s. So 1 5, 2 5. Similar here, 1 5, 2 5, 1 5, 2 5. So the question is, what are the number of factors? Or rather, how many 5s do I actually have? And if you guys counted right, then we know we have 6 here. Okay, we have 6 5s. Okay, so if I wanted to write this as a product of a power, I would have to write 5 to the 6th power. Or in other words, I have 6 5s being multiplied. Okay, so hopefully you guys can already start to see why we call this multiplying exponents. Okay, because notice that 2 and the 3, what is 2 times 3? Well, it's 6. And look at that. What was our answer over here? That's exactly what it was. It was 5 to the 6th. Okay, so let's go ahead and do this next one together, and I'll have you guys try out one of the example problems underneath. So this next one says x squared and then raised to the 4th. So what does that mean? It means I have 4 x squareds. Okay, that means I have 4 x squared. So let's count them again. 1, whoops, wrong thing. I'm supposed to use a highlighter there. Okay, so x squared, x squared, x squared, x squared. So I have 4 of them. But now I know that each one of those splits up into x times x. And yet again, x times x, x times x, and x times x. So let's count them out now and see how many we have. So we have 1, 2, 3, 4, 5, 6, 7, 8. So it's asking how many factors of x do I have here? Well, I have 8 x's. Okay, so if I want to write this as a product if I want to write this product as a power, I would go ahead and write x to the 8. And if you guys remember what we did earlier, we said that we're essentially multiplying the exponents. So let's see if that's true. What's 2 times 4? That should be 8. And look at that. That is 8. Okay? Alright guys, I think you guys have enough to try out a few on your own, but let's just go ahead and read this last comment. It says, what did you notice when you wrote the product of factors into a power? Well, you should have noticed, and like I explained a little earlier, you should have noticed that you must multiply the exponents. So, again, notice it's just that one base raised to a power and then to another power. All you have to do is multiply the exponents. So why don't you guys go ahead and do this for me? Why don't you guys go ahead and pause the video right now and try out 2a through 2c. All right, hopefully you guys had a chance to try those two out, or I'm sorry, those three out. So if we go ahead and follow this rule, we technically just have to multiply that 6 times 2, which would be 12. So this should be x to the 12. Okay, and if you guys notice, it is right here, so I can cross that out. Same thing with my next one. So my base is 5, and my exponents are 4 and another 4. And we know with two exponents, what I have to do is multiply them. So 4 times 4 is a 16. So this is actually written as 5 to the 16. And look at that. That is also one of my choices. All right, this next one's a little tricky, guys. I want to make sure that you guys understand how to do it. And what I'm going to do is actually this. First off, what I want to do is this. I'm going to write, whoops, that didn't look so good. So let me actually redo that. So I'm going to put a 1 there and a 1 there. And what I'm going to do is for a second, just for a little bit, I'm going to go ahead and block that out. What would you tell me the answer is now? Okay. Well, I hope that you guys are telling me that it would be x to the 4th, right? Because 1 times 4 is just 4. Now let me bring back that y. Now I'm going to block out the top part. Okay, now what will we get? Okay, well, you guys should notice that it's the same thing. What's 1 times 4? That should be just a 4. So I should get in the bottom a y to the 4th. And now I can finally erase all this stuff. And you guys can start to see that my answer should be x to the 4th, y to the 4th. And lo and behold, this down here. Okay. All right, guys. So hopefully you guys did pretty well on those. If not, just make sure you either rewatch that part of the video or just continue practicing, guys. Sometimes all you need is to actually just practice it, and then you will actually understand what's going on. Okay? All right. So the next rule that we're going to talk about is the power of a product rule. Okay? This one is basically called distributing exponents. Okay? So with 3a, let me go ahead and do something very similar to what I did earlier. So let's go ahead and remember what we can write as an exponent for this w, x, and y. If you guys remember, I said if you don't see an exponent there, then it's a 1. So each one of those has an exponent of 1. And what I'm going to do right now is pretend that I didn't have the w and the x and I just had the y. Let me go ahead and do that. Let me go ahead and block that out with my black highlighter here. Okay, so I just have y to the 1 and then raised to the 4th. Well, we just did that, guys, right? Didn't we just do that? Okay, so let's go ahead and write the answer. That would be y to the 1 times 4 is 4. Okay, cool. But we didn't just have y, we had w, x, and y. But what I'm going to do now is yet again block out my w and block out my x. I'm sorry, block out my y rather. See if I can do this. There we go. So the only thing shows here is a x to the 1st and then raised to the 4th. And yet again, you should be able to tell me that the answer to that is x to the 4th. And then finally, I'm going to do the same thing all over again, but now for my last variable here, which in this case would be the w. Again, this is w to the 1st. So w to the 1st and then raised again to the 4th would be w to the 4th. So now let me erase this, and now I'm going to show you exactly what I did. So we just took it and broke it down step by step, but now notice this is all I really did. Notice I have an exponent in here of 1. and I have this exponent over here of 4, I distributed that 4 to each one of those exponents. Okay, and when you're distributing, remember, what does that mean? All that means is you're multiplying. So you do w to the first and then raised to the fourth, so it's just 1 times 4. So w to the fourth. Again with the x, 1 times 4, that means x to the fourth. And then the same thing with the y, 1 times 4 is y to the fourth. So then your final answer here is this entire thing. So it's just w to the fourth, x to the fourth, y to the fourth. Okay, I'm going to do one more with you guys, and then I'm going to have you guys try out the rest on your own. Okay, so let's go ahead and look at problem number 3b. And just like before, I'm going to go ahead and pretend that this isn't even here. So what would my answer be there? Well, it's a base of m raised to the fifth and then raised again to the second, so I'm applying that power rule. Okay, so this is 5 times 2. So this is m to the 10th. Okay, I'm going to go ahead and erase this. Now I'm going to do the same thing, but now with my bottom piece, which is that n. So I'm going to go ahead and grab my pen here. So notice again, this is 7 times 2. So this is n to the 14th. Let's go back and analyze exactly what we did. Well, again, I did the exact same thing I did with 3a. I distributed this 2 to my other powers. So 5 times 2 was 10. 2 times 7 was 14. So my final answer is m to the 10th, n to the 14th. Okay? All right. The only thing that I'm going to give you for part C is this. That 2, just like the exponent, I'm sorry, just like the variables, also has an exponent, and it's just a 1. So go ahead and try the similar process and see if you can figure out 3C, 3F, and then we'll come back to talk about it. All right, guys, let's go ahead and try out number 3C here. So if we keep doing that distributing part, I'm going to just distribute that here and distribute that there. So remember, guys, on that first one, that 1 times 3, I have a base of 2. So don't forget to write it. So it's base 2, and then 1 times 3 is a 3. And then base x, and then you do that 2 times 3, which is 6. Okay, I can go one step further, guys. I can actually figure out what 2 to the third is. And if you guys type that into your calculator, just go ahead and do 2 raised to the third. You should get 8. And then don't forget to drop that x to the 6th. So your final answer here should be 8x to the 6th. Again, if you're not sure how I got that 8, guys, remember that 3, all it's telling you is how many factors of 2 you have. So if you do 2 times 2 times 2, that should be 8. Okay? All right. Same thing with 3D. That 4 has an exponent of 1. That m has an exponent of 1. Now I can distribute 1, 2, 3. Because I have 3 bases, I have a 4, an m, and an n. So I'm going to do 4 to the something, m to the something, and n to the something. So let's figure out what those somethings are. So that 4 to the 1 and then times 2 should be a 2. 1 times 2 is also 2. And 6 times 2 is a 12. Okay, not quite done yet because I can figure out what 4 to the second is. 4 to the second is like 4 times 4. So that is actually 16. M to the second, n to the 12. And again, guys, you can confirm all these answers here. 3a was this one. 3b was this one. 3c was this one. And now we just figured out 3d, which is that one. Okay? Keep going, guys. Okay? 3 times 2, 3 times 5, and 3 times 8. So this is A, B, and C. Now you just have to figure out your exponents. So 2 times 3, that's a 6. 5 times 3, that's a 15. And 8 times 3, that's a 24. Let's verify. Is it on here? Yes, it is. It's right there. Last one. We'll run through it pretty quickly. Again, this is a 1 if there's no exponent, and that's another 1 if there's no exponent. So again, I have how many bases? 1, 2, 3. So rewrite them. 1, 2, 3. Now just distribute 1, 2, 3. So 1 times 3 is 3. 5 times 3 is 15. And 1 times 3 is 3. I can go one step further. Again, 2 to the third we already talked about. That's just 8. J to the 15th. K to the third. Is that one of our answers? Yes, it is. It's right there. That is what's called the power of a product rule. Okay. So the final rule that we're going to take a look at is the division of exponents rule. Okay. So with division of exponents, all we're doing is subtracting. If you guys remember when we were multiplying exponents, or I'm sorry, when we were multiplying the when we were multiplying things with the same base, we would add the exponents. Well, now when we're dividing things with the same base, we're actually going to subtract exponents. Let's go ahead and look at what we have here. So it says when dividing powers with the same base, you subtract the exponent. So exactly what I just mentioned. Okay. So it says hint, ask yourself who wins, the bottom or the top. Okay. So we're going to keep that in mind, guys, when we're going through these two problems. All right. The first one says x to the 7th, so just so we're on the same page here, this is the problem I'm looking at. X to the 7th over x to the 4th. Okay, so we're going to ask ourselves that same question. Who wins here? Well, does the bottom, or I'm sorry, does the top have more x's or does the bottom have more x's? Well, the top does, right? X to the 7th is obviously bigger than x to the 4th. Well, how many more does the top have than the bottom? It has Whoops. It has exactly 3 more. So what you're going to do is go ahead and write x to the third because the top had more. So that's where I'm going to write the 3 at the top. So x to the third on the top. And since the bottom was lower, I'm just going to go ahead and write a 1 there. Okay? But we know that anything over 1 is just that same thing. So my final answer here is just x to the third. Okay, so again, this is a scenario when the top wins. Let's look at what happens when the bottom wins. Okay, so we have p to the 9 over p to the 12. Well, which one has more, the top or the bottom? Well, the bottom has more, okay? Then you ask yourself, well, how many more did the bottom have than the top? It had exactly 3 more, okay? The bottom had 3 more, so that's where you're going to put your p at the bottom. And then here at the top, you're just going to go ahead and put a 1, okay? You always just end up putting a 1 wherever the loser was, basically, okay? So whichever wins, that takes the same base with that exponent, and then whichever loses, that's where you just go ahead and write your 1, okay? Well, especially when we're talking about variables. If we're talking about numbers, then we actually have to go into a little bit more of a discussion. But for now, let's go ahead and go with that. So let's go ahead and take a look at this next problem. It says that you have to do this one. So what I want to think of this as, well, let's actually, why don't we go ahead and draw our line first, just to make sure we're all on the same boat here. Okay, well, let's pretend for a second I had this. This is 9 divided by 3, okay? Well, 9 divided by 3 is what? Well, it's 3. And that 3, where do you think it goes? You think it goes on the top or the bottom? Well, it goes on the top. Because which one was larger, the 9 or the 3? Which one wins? The top wins. Okay, so that one goes in the top, and then because the bottom one was the loser, I'm going to put a 1 there. Okay, same thing now with my variables, because now if I block these out, I have a similar problem to what I just did over here on the left side, to what I did over there, right? Okay, so let's take a look at it. So m to the 12th over m to the 2nd. Which one wins? Okay, which one has more? The top one has more. Okay, so as soon as you say the top one has more, write the m on the top. Okay, write that base. Okay, now the final question is, how many more did the top have than the bottom? Well, it has exactly 10 more. Again, if you're wondering still why or how I'm getting those numbers, just take your exponents and, like we said here, subtract them. So it was 12 minus 2 is 10. That's the number I'm putting here for my exponent. Okay? All right. I think you guys have enough to at least try out 4A through 4C. So just to make sure that you guys get enough practice, why don't I let you guys try those out? So go ahead and pause the video right now, and then we'll go through everything on those 6 problems. All right, guys, let's go ahead and take a quick look at this. So again, here I'm dividing an x to the 8th divided by x to the 2. So I'm definitely going to have that division sign. Okay, but now I ask myself, which one wins, the top or the bottom? Well, the top one has 8 x's, and the bottom one has 2 x's. So which one wins? The top wins. And as soon as I say that the top wins, I'm putting my base there. I'm putting my x there. Second question you ask yourself is, how many more did it win by? Or how many more does the top have than the bottom? Well, there's 6 more. Again, if you're not sure how I got that, do the 8 minus 2. Okay, that's just 6. And what goes on the bottom always? Well, a 1. Okay, or whatever lost. In this case, the x to the 2 lost. So go ahead and put a 1 in that spot. Okay. Now, this one, if you guys wanted to, and I would recommend it, most of your teachers will tell you to do this, just read it as x to the 6th, okay? That's just telling you that you could put anything over 1, so why don't you just basically simplify it and put it as x to the 6th, okay? All right, next one, y to the 3rd over y to the 5th. Which one wins? Well, the bottom one wins, so I'm going to put my y there. How many more does the bottom have than the top? It has exactly 2 more. So in the loser spot, that y to the 3rd is going to go a 1. Now be careful with this one. This right here, I just want to make sure we're clear on this, is not the same as this, guys. This x to the 6th over 1, I was able to rewrite as just x to the 6th because the 1 is on the bottom, okay? This one has the 1 on the top, so I can't reduce that. I need to leave it like that, okay? So this is my final answer, 1 over y to the 2nd. And I don't know why I used the highlighter. 1 over y to the 2nd is my final answer. You cannot get rid of that 1 at that point. This is not the same as y squared, okay? So just so you know, you can only get rid of that 1 if the 1 is on the bottom. All right, part C, let's check it out. So again, look at the numbers, guys. Look at those two front numbers, the 16 and the 2. Well, what's 16 divided by 2? That's 8. Okay, which one was bigger, the top or the bottom? The top was bigger, so I'm going to put the 8 on the top. Okay, now let's just look at our z's. So it's z to the 5th over z to the 3rd. Which one has more? The top has more. So I'm going to put my z there. How many more did the top have? It had 2 more. Okay, again, on the loser spot, usually is the 1, but because the 1 is in the bottom, I can just simplify it to 8z to the 2nd. Okay, this is just a repeated pattern, guys. It doesn't matter how many variables or exponents are on top, and it doesn't matter how many there are on bottom. You just repeat the process. So if you guys look at 4D, I have A's and B's. We'll just concentrate on the A's first. So let's look at the A's. I always like to draw my fraction bar first, though. Okay, let's look at the A's. Which one wins? Which one has more? The bottom has more. So that's where I'm going to put my A. How many more does it have? Well, let's see. It's 15 minus 2. That is 13. So 13 is what I put there. Now let's look at my B's. Okay, well, the B's, the top one has more. So my B is going to go on top. How many more did it have? It had exactly 2. And my fraction bar is a little big, so I'm going to make it a little smaller. Okay, this is my final answer. Keep going, guys. Okay, let's check this one out. Again, I like writing my fraction bar first. If you don't want to, that's totally fine. This one, I hope it doesn't become tricky on you guys, but I think you guys will understand it if we talk about it. Okay, 5 and 25. Those are the two big numbers, okay? Those are the ones we have to try to reduce first. Okay, well, what do 5 and 25 have in common? Well, they have a 5 in common. So what would be 5 divided by 5? That would be 1. What's 25 divided by 5? That would be 5. Okay, notice I had to find a common factor in order to, I'm sorry, common divisor, I should say, that they both are divisible by, and that's how I was able to divide them. Okay, so now I can concentrate on my variables. Well, I have two s's here. Okay, and then s to the 6th here, and then s to the 15th. Which one has more? The bottom has more. Okay, so the bottom gets the s, and then how many more does the bottom have than the top? It has 9 more. And then the t, well, there's nothing else there. There's no other t's. So the t just has to stay exactly as it is. So t to the 3rd. Okay, so this right here is your final answer. For some of you guys, since you notice that it's 1 times t, honestly, you can get rid of that 1. You could just leave it like that. Most teachers, again, will probably tell you to do that. But it is technically not wrong to put that 1 in front. Okay? All right. I think I pretty much made my point clear on those. I just want to make sure it makes sense here. Again, you're asking yourself who wins with those, who wins with those, and there's only D's on top, so you keep that D on top. Okay? Oops. Wrong pen here. So put that D on top. That one just stays at 18, and then you can go from there. I'm not going to go ahead and finish that. Okay? All right, so I think what we're gonna do now is just go through a few of these final review problems, and then I'm gonna have you guys on your own, and we will be done with this video. Okay, so let's go ahead and take a look at number 1. Okay, well, let's go back through our rules. We had the product rule, which is when we have the same base, so we have to add the exponents. We have whoops, did I skip it? The power rule, which is when you multiply if there's 2 sets of exponents. We have the power of a product rule, which is when you distribute that exponent from the outside into every exponent on the inside of the parenthesis. And then finally, there's the rule 4, which is the division of exponents, which is when you basically ask yourself who wins, or you ask yourself, where do I have to subtract? Okay, so this first one, it looks like a product of 2 similar bases. The 2 bases here that are the same are the r's, and because I'm multiplying something with the same base, I know I have to add the exponents. So this is technically like 3 plus 2, so it's r to the 5th. Simple enough. Okay, for number 2, notice that's just an exponent, or I'm sorry, a something being divided by something else. Okay, so x to the 7th divided by x to the 18th. That's the division. Okay, so that's the division rule. We know we have to subtract there or ask ourselves which one wins. In this case, which one wins, guys? Well, the bottom wins, so I'm going to put my x there. How many more does the bottom have than the top? Well, let's take that bottom number. Subtract from the top number, I get 11. So I have 11 more x's on the bottom than on the top. And in the loser spot, what do we put? We always put that 1. So my answer here is 1 to the x. 1 over x to the 11th, I should say. Okay. Number 3, we have the product of, or the power of a power, basically. So we have to multiply the powers, or the exponents. So 4 times 8 is a 32. And we keep the base of m. And I feel like this is just redundant at this point. So what I want you guys to do is try a few out on your own, and I'll pick out some key ones that I need to make sure that you guys understand before we move on to the next section. So go ahead and pause the video right now and try out a few on your own. Okay, guys, so as you guys may notice already in this problem right here, so let me go ahead and highlight it. This is the division rule, right? Okay, again, which one wins? This we just reduce, and then here you ask yourself which one wins. So I'm not going to go over that one. I feel like you guys have a solid understanding of that one. Here, I do want to go over number 5 though. Take a quick look at number 5. So I have a big 5 and a big 3, so those are just regular bases. So what is 5 times 3? Well, that's just 15. So that's 15. And now, do I have two things with similar bases? Yes, I do. I have this y to the 4th and y to the 9th. And we said that when we're multiplying something with the same base, then, whoops, then all I have to really do is add the exponents. So that's what I'm going to do. So this will be y to the what? 4 plus 9 is 13. So 15y to the 13. Okay? All right. So let's see. Number 8, again, it's that who wins type of problem. So between those two, which one wins? Between those two, which one wins? So I'm not going to go over that one. I feel like that one is probably the easiest to understand. I do want to go, however, over one of these. Okay, remember this 3 right here on number 6 has a exponent of 1, and so does this d here. And because we have already powers in each one of these variables and numbers, and then it's raised to another power, we're doing that power of a power rule, so we're going to have to distribute to each of those powers. So again, how many bases did I have? 1, 2, 3. So I'm going to write my bases 1, 2, 3. And then we just multiply. So 1 times 3 is a 3. 5 times 3 is a 15. And a 1 times 3 is a 3. Okay. Now, again, teacher might tell you, well, that 3 to the 3 is what? So actually multiply it out, guys. Then type it in your calculator as 3 to the 3rd power, or just type in 3 times 3 times 3, and you should end up with 27 c to the 15th d to the 3rd, and that is your final answer. Okay. All right. I think I'm going to leave you guys off there. I think maybe I will do one of, actually, why don't I do one of these challenge problems for you guys? Okay. So just to make sure you guys are understanding these challenge problems, let's take a quick look at number 12. Okay. Number 12 here. Well, let's see. First off, inside of that parentheses, can I combine anything already? I already have two things with the same base. Let me just use a different color. I have this j here and this j here. So I can add their exponents. So this is really 5 to the 1st, j to the what? 5 plus 4 is 9, and then finally k to the 3rd, and that all is being raised to the 2nd, and now I know I can apply my power of a power rule, where I distribute this power to all my remaining powers. So write down all of your bases, which is 5, j, and k. And now let's figure out what the multiplication would be. So 1 times 2 is 2. 9 times 2 is 18. And 3 times 2 is 6. I can figure out what 5 to the 2nd is. That's just 5 times 5. So my final answer here is 25, j to the 18th, and k to the 6th. Alright guys, I won't stretch this video any longer than it has to be. So I already went over my 40-minute mark, which is more than what you guys need. But again, I like to go over as many of these problems with you guys just to make sure you guys have examples on multiple of them. I know after a while you guys might be like, oh, this is redundant. I know how to do this. That's why you guys have the ability to, you guys have that ability with these videos. But just make sure you always come back and watch these videos if you do have any questions on any of these sections. Okay. All right, guys. Well, I'm going to end it there, and I think we are good for now. So go ahead and stop the video at this point, and I will talk to you guys later. All right. Bye.